Now when we talk about two charges and the Coulomb's force between the two charges, things remain simple. We can determine the, for example, these two charges, we can determine the force on the charge, this positive charge because of this negative charge, or vice versa. We can simply determine if two charges are involved. But what happens when instead of two charges we have three charges? So for example, here in this configuration we have three charges. So there is a principle which is known as principle of superposition, and we are going to talk about that in a minute. But what is the basic idea? The basic idea is that, let's say that I am trying to determine the charge between these two bodies, Q1 and Q2, and I have placed this third body, Q3, at such a large distance that it is not affecting my system. Okay. And now I have determined the charge between this Q1 and Q2, and I have found it to be F. If I bring in this third body right here, okay, and place it near, let's say, Q1 or Q2, it does not affect the original force F between Q1 and Q2. So the interaction between the two charges Q1 and Q2, it remains exactly as before, no matter how many such other charged bodies are kept in the vicinity. Okay, the interaction between Q1 and Q2, between those two charges, can be treated independently of the interaction of, for example, let's say Q1 with all the other bodies which are present there. So what does it tell us? It tells us that if I want to find in the diagram C, if I want to find the charge on Q3, I can first take, if I want to take, not find charge but force, if I want to find the force on the charge Q3, then I can separately take the forces which are exerted by charge Q1 and Q2 independently of each other, because just because Q1 and Q2 are present simultaneously, it does not mean that the force of Q1 would be affected by Q2, or force of Q2 on Q3 would be affected by Q1. Okay, so that is what we are saying. So what does that mean? It means that I can understand the force between Q1 and Q3 treating as if this charge Q2 is not present at all. Okay, just by ignoring charge Q2, I can understand what is the force exerted by Q1 on Q3 and write it here. And then just by after that, I would ignore this charge Q1 and calculate the force exerted by Q2 on Q3 and write it right here, and then I can add it together. So this is this principle of superposition. We will consider each of the charges, each of these interactions individually, and we can simply add them together, and we can do that because the presence of other charges does not really affect, just because Q1 is present, it does not really affect the interaction between Q2 and Q3. And because there is no effect of Q1 on this interaction, I can just calculate the force on Q3 because of Q2 as if the Q1 were not even there. Okay, so that is what I have calculated here, and the force of due to Q1 on Q3 I have calculated here, ignoring Q2 completely, and that this is the total force on Q3 exerted by both the charges 1 and 2. Now this principle of superposition is very, very important, because here it has come in a simple form, but if this various Q's are small and distributed all across, then this summation actually can be converted to integration, and we can continue to use the same superposition principle by changing this summation to integration. And that is what we will discuss in the next class. That is what we will talk about when we discuss the Gauss law. Again, very, very important. So if you want to understand Gauss law, subscribe to the channel. And principle of superposition allows us to solve numerical problems very, very easily. So definitely practice those on doorsteptutor.com. We have put in several problems on superposition of charges. Thank you.